Suppose we have the arctangent of square root of 3, which could also be the tan inverse of the square root of 3. And I want to find an angle, theta, for that. That's in the interval negative pi over 2 to pi over 2. Which is good because that's what the arctan knows about. So I don't have to mess around with the unit circle and translating an angle. So then it does, do I remember what the arctan has to do with the square root of 3? And so then I'm just going to think about the unit circle. So again, another way to think about this is the tangent of what angle is the square root of 3. And if I think about the unit circle, if I don't have that memorized, I should think about my first quadrant angles. All right, pi over 6, pi over 4, pi over 3, pi over 2, and then the points I have to go with those, which would be 1, 0, square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, 1/2, square root of 3 over 2, and then up here 0, 1. What do we know about the tangent? Well, there's two ways to think about the tangent. It's the slope of the radius, or it is the y value over the x value of that point. So which point there has a slope of square root of 3, or y over x is the square root of 3. And I'm looking at that point right there, because if I take the square root of 3 over 2 and divide by 1/2, the halves divide out and I get the square root of 3. And so that lucky angle right there is pi over 3. So I believe that the arctangent, the square root of 3, is pi over 3, and we can check that on a calculator by plugging in what is the arctangent of the square root of 3. Plug in pi over 3, and I should finally have the same decimal value. So again, knowledge of special angles is important. Sometimes we do need exact answers. Let's try another.